Hello, I'm Papia. In this problem, we have a vector-valued function r of t, and we have to evaluate this function at various t values that's given to us. So the first one, we have to find what is r of 1, which means when t is equal to 1, what do we get? So this is just evaluating a function at a point that you have done before. The only difference is now you have a vector-valued function. So you take the expression that's given to you for this function and plug in t equals 1. Okay? So we will get half times, see we have a t square. So instead of t, write down 1 square. And the second component is negative t plus 1. So negative of 1, because t is 1, plus 1. So simplify, and we get 1 square is just 1 divided by 2. So this is 1/2. And negative 1 plus 1 is 0. So this is r of 1. And we continue. So next we have to find what is r of 0. So when t is equal to 0. All right. Let's go back to the expression again. Plug in t equals 0. So we get 1/2 times 0 square, comma, negative of 0 is just 0, plus 1. Okay, so the first component is 0 square is 0, 0 over 2 is just 0. And second one is 0 plus 1, so this is 1. All right, for part C, we have to figure out what is r of s plus 1. Now don't get confused because this is not a number. This just means that we are plugging in this entire expression s plus 1 wherever there is t. Okay, so we have 1/2 times t square. Instead of t, write s plus 1 square. And for the second component, we have negative t. Instead, write negative of s plus 1 plus 1. So please be careful to put this bracket so you know that the negative sign will distribute. All right. Notice that we don't have to simplify this first component. Just keep it as it is, 1/2 s plus 1 square. For the second one, we will have negative s, negative 1, plus 1. So the 1 minus 1, this will cancel, and you will end up having 1/2 s plus 1 square and negative s. Okay. Finally, for part D, we have to evaluate this entire expression. So what is r of 2 plus delta t minus r of 2? Now, we do the same thing. Write down each expression for these two different t values, and then we'll simplify. So let's start with the first one. For the first expression, we have to plug in this entire expression 2 plus delta t for t. Okay, so we have 1/2 t square. Instead of t, write 2 plus delta t, the entire thing square, comma. For the second component, we have negative t plus 1. So again, write negative of, instead of t, write 2 plus delta t, then plus 1. So that's just the first expression. Then you subtract. For second expression, we have r of 2. So do the same thing, plug in t equals 2. So we will have 1/2, remember 1/2 t square, so 1/2 times 2 square, and negative t plus 1, so negative 2 plus 1. Plugging in t equals 2. Okay, let's simplify. For the first expression, we have 1/2 times 2 plus delta t square Then we have negative 2 plus 1, that's a negative 1, and a negative delta t. And you're subtracting. 2 square is 4, 4 divided by 2 is 2, and negative 2 plus 1 is negative 1. Okay. Well, we can combine the two together. So you subtract the first components and we get 1/2 2 plus delta t square minus 2, comma, and then subtract the second components. So negative 1 negative delta t, negative of negative 1. So this becomes positive 1. Okay, we can expand this complete square and then add the two terms together to simplify this. Okay, so let's do that. Let's have a common denominator of 2. In the numerator, we will have 2 plus delta t square minus 2 times 2, 4. And for the second term, we will get rid of the negative 1 and positive 1. You will just have a negative of delta t. Okay, now let's expand the numerator. We have 2 square, that's 4, plus 2 times 2, that's 4 times delta t, plus delta t square minus 4 divided by 2. And we already have the simplified form for this second component. So after cancelling this 4, you can simplify this expression. See, the first term, we have 4 times delta t. You can divide that by 2 to get 2 times delta t. And the second term is just delta t square divided by 2. This is plus 1/2 delta t square. And second component is just negative of delta t. So this is the expression, final expression for r of 2 plus delta t minus r of 2. So we have evaluated this function at various t values. Thank you.